Hello and welcome to the Amazon Web Services webcast for the Amazon Elastic File System, or EFS. My name is Edward Name and I lead product management for EFS. And let me begin by discussing the goals of the webinar and setting expectations. The overall goal is I want you to walk away from the session with an understanding of what EFS is, what its features are, and how it can help you. And the webinar is intended for all levels. I'll cover both beginner topics and more advanced concepts. And as I mentioned, I'll do a Q&A at the end where I'll share some of the questions that have come in from the chat lines. So what specifically will I cover? First, an overview of EFS, how it fits into our storage portfolio, what its key features are, and why those features matter. Second, I'll dive in. I'll talk about EFS from a more technical perspective. So we'll focus on what it means to set up a file system and how you access a file system from an EC2 instance. Then I'll show you what it looks like to create a file system through the console, so you'll see for yourself how you create and access a file system. Fourth, because data security is critical for all customers, I'll spend time sharing some of the security features you get with EFS. And then finally, I'll talk about how EFS spreads data across data centers and what that means from a data availability and a data durability perspective. So let's jump into it. And let me start by talking about our current storage offerings and how EFS enhances our set of offerings. Before EFS, so until a few weeks ago, AWS had three storage offerings for customers. The first is the Amazon Simple Storage Service, or S3. Second is Amazon Elastic Block Store, or EBS. And then the third is Amazon Glacier. Let me talk about each of these. S3 is object storage. An object is a piece of data like a document or an image or a video that's stored with some metadata in a flat structure. And S3 provides that data to applications via an API that's accessed over the internet. And with S3, it's super simple, for example, to build a web application that delivers content to users, again, by making calls to the API over the internet. EBS is block storage for EC2 instances. And data with EBS is presented to your instance as a disk volume. EBS provides low single-digit latency access to single EC2 instances. And EBS is very popular, for example, for boot volumes and databases. And Glacier is archival storage. It's our lowest cost storage offering, and it's intended for data that's accessed pretty infrequently. And now we have EFS. And EFS is file storage. Data is presented to instances via a file system. And when attached to an instance, EFS acts just like a local file system would. And EFS can provide shared access to data to multiple EC2 instances with very low latencies. So what are the features of EFS? Well, it's a fully managed file system for EC2 instances. There's no hardware to maintain, no file software layer to maintain. It's fully managed. It provides standard file system semantics. So you get what you'd expect from a file system. Read after write consistency, the ability to have a hierarchical directory structure, file operations like appends and atomic renames, and the ability to write to a particular block in the middle of a file. EFS works with standard operating system APIs. So EFS appears like any other file system to your operating system. So applications that leverage standard operating system APIs to work with files will work with EFS. EFS is shareable across thousands of instances. It can act as a common data source for applications and workloads that span multiple EC2 instances. EFS elastically grows to petabyte scale. When you create a file system with EFS, you don't specify a provision size upfront. You just create the file system and it grows and shrinks automatically as you add and remove files and directories. EFS delivers performance for a wide variety of workloads. It's SSD based and it provides low latencies, high throughput, high IOPS, so performance that you can really count on for a very wide variety of applications and use cases. EFS is also highly available and highly durable. EFS replicates data across AZs within a region, and what that means is that your files are highly available, they're accessible from multiple AZs simultaneously, and they're also well protected from data loss. And EFS is NFS v4 based. And NFS is a network protocol for interacting with file systems. In the background, when you connect an instance to EFS, the data is sent over the network via NFS. And NFS is an open standard, it's widely adopted, and NFS clients are included in virtually all Linux distributions. EFS is designed for a broad range of use cases, and let me walk you through a few examples. Content management systems store and serve information for a wide range of applications, for example, online publications or reference libraries. EFS can serve as a durable, high-throughput backing store for those types of applications. Development and build environments often have hundreds of nodes accessing a common set of source files, binaries, or other resources. And EFS can serve as a storage layer in these environments, providing a high level of IOPS to serve demanding dev and build needs. Many organizations provide storage for individual and for team use. For example, research scientists commonly share data sets that each scientist may perform ad hoc analyses on, and these scientists also store files in their own home directories. With EFS, an administrator can create a file system where parts of it are accessible to groups in an organization and parts are accessible to individuals. And big data workloads often require file system operations and read after write consistency, well as the ability to scale to really large amounts of storage and throughput. EFS can serve as file storage that EC2 clusters can work with directly for those types of workloads. So why did we build EFS? Well, because operating shared file storage today is a pain. If you're an IT administrator providing file storage for your company, you need to estimate storage demand for the many groups and organizations you're supporting. You need to procure hardware, so you need to evaluate different hardware options. You need to estimate costs and maybe build a few cost models. You need to work with your procurement team. You need to track orders. You need to set aside physical space for the racks that you're setting up. You need to set up and maintain hardware. And if the network's not sufficient for the throughput you want to drive to your storage, you may need to upgrade your network. And you need to perform constant monitoring of access. You need to monitor for security breaches, etc. If you're an application owner or developer, you need to estimate your need for storage. So you need to spend time building a case for why you need the space, why the organization should make such a large capital investment. Your procurement times can be really long, and storage is not necessarily available when you are as a result. So you need to worry about how quickly your data set might grow, and you need to plan and build lead times around that. And you can't be as agile as you might want. You can't run quick experiments. You can't spin up and spin down storage quickly and pay only for what you're using at a given time. And then as a business owner, you need to make upfront capital investments for equipment. You need to overbuy because of the long lead times and not wanting to run out of space. And in steady state, you're never going to want to completely fill your disks anyway, because generally bad things happen when you do that. And most importantly, or worst of all, you're diverting attention away from your business mission. With EFS, we set out to change the current state. And if there are three things I'd like you to remember from today's presentation, it's the following three things. And these three things are interrelated. The first is that EFS is simple. The second is that EFS is elastic. And the third is that EFS is scalable. So let me talk about each of these in turn. EFS is simple. It's a fully managed service. It's simple to administer file systems at scale. There's no file layer or hardware to manage, and that eliminates the ongoing maintenance and the constant upgrade and refresh cycle. There are no volumes to manage, no LUNs, no RAID groups, no provisioning management, none of that stuff. And with EFS, you can create a scalable file system in seconds. And that's probably hard to believe for folks on the call who've managed shared file storage, but I'll show you later in the session what it really means to create a file system and what that looks like so you can see for yourselves. EFS provides seamless integration with existing tools and apps. As I mentioned, it supports NFS v4, which is a widespread and open protocol. It provides standard file system semantics, and it works with standard operating system APIs for interacting with files. And it's simple pricing. You pay a per gigabyte per month amount that's based on the amount of storage. EFS is elastic. File systems grow and shrink automatically as you add and remove the files. There's no need to provision storage capacity or performance. In fact, there's no way to. It's completely elastic. And again, as I mentioned, you pay only for the storage space you use. And it's scalable. File systems can grow to petabyte scale. No need to reprovision, adjust performance settings, or do anything in order for your file system to grow to petabyte scale. EFS just takes care of it all automatically as you add files. Throughput and IOPS scale automatically as file systems grow. So with each gigabyte stored, you get a particular amount of throughput and IOPS, and that ensures that as the amount of data that you're working with grows, the amount of throughput and IOPS available to work with that data also grows. Provides consistent low latencies that are independent of file system size. So regardless of the size of your file system, you'll see similarly consistent low latencies. And lots of file workloads are latency sensitive. So this was an important part of our design. EFS is SSD based, and low latencies were core to a lot of the work we did to deliver this service. And EFS provides support for thousands of concurrent NFS connections, which really allows it to be used as a common data source in large clusters, or more broadly for use cases where there are many nodes that are accessing a single source. So now coming back full circle, why does all of this matter? To IT administrators, EFS eliminates the need to manage and maintain file system storage at scale. To app owners and developers, makes it easy to move existing code, applications, and tools that are used today with existing NFS servers to the AWS cloud. And it's also a simple shared file storage solution for new cloud native applications that are built from the ground up to work with the cloud. And to your business, EFS provides predictable pricing with no upfront investment, no capital investment, increased agility, and EFS allows you to spend less time managing file storage and more time focusing on your business and on value add. Okay, so let's dive in and let's talk about EFS from a more technical perspective now. And for those attending the webinar who are new to AWS, before getting into EFS specifics, let me define a few AWS building blocks, specifically a region, an availability zone or AZ, and a virtual private cloud or VPC. A region is a geographic area where AWS services are available. Each region is designed to be completely isolated from other regions, and that achieves the greatest possible fault tolerance and stability. Customers choose regions for their AWS resources. So, for example, when you launch an EC2 instance, you select the region it should be in. And customers can select a region based on, for example, latency requirements or legal requirements. And today there are 11 regions worldwide, and that number is growing. An availability zone or AZ, what that is each region has multiple isolated locations, and these are known as availability zones. And really they're a logical group of data centers. Availability zones have low latency links between them within a region. And when launching an EC2 instance, a customer chooses an AZ. So the customer will choose the region that the EC2 instance should be in, and then also the AZ that it should be in. And note that some customers distribute their instances across multiple AZs to have extremely high fault tolerance. And today we have 28 AZs worldwide. And then a virtual private cloud or VPC. It's a logically isolated section of the AWS cloud. It's essentially a virtual network that's defined by the customer. And when launching instances and other resources, customers place them in a specific VPC. So customer will choose the region, the AZ, and the VPC to place an instance in. All new customers have a default VPC, and customers can create new ones as well. Okay, so getting back to EFS. What is a file system? A file system is the primary resource in EFS, and it's where you store files and directories. So pretty basic concept. And how do you access a file system from an instance? You mount the file system on an EC2 instance, and mount is a standard command. And once you mount it, the file system will appear like a local set of directories and files. And an NFS v4 client must be installed on your instance, and those are available on most Linux distributions. what you see on the bottom half of the slide is a mount command that you would use with EFS. Let me just explain what parts of it are. So the -T is for file system type. So with EFS, you're mounting an NFS4 type file system. You specify the file system's DNS name, and I'll walk through what that means in a second and how you get that. And then the final piece, the user's target directory, is the local directory that the file system will be attached to and appear at. On the previous slide, I mentioned the DNS name. That was in the mount command. And this is something that's created when you set up your file system. And DNS names resolve to the address of something that we call a mount target. So what is a mount target? Well, to access your file system from instances in a VPC, you create these things called mount targets in the VPC. And really a mount target is an endpoint in your VPC to the EFS file system. And a mount target has an IP address associated with it, and the DNS name that I was referring to resolves to that IP address. So when you're mounting your file system, you provide a DNS name, it resolves to the IP address for the endpoint. So how does it all fit together? Well, you have a region, and you have a VPC spanning multiple AZs, and you have EC2 instances in those AZs, and the EC2 instances have, and the VPC has these mount targets, which are these purple dots that you see, and the EC2 instances connect to the file system through those mount targets. And we provide an API that allows you to administer your EFS file systems. And all of the API's functionality is available to you in 3 ways. The first is through the AWS Management Console, and that's our browser-based management tool. The second is through the AWS Command Line Interface, or CLI. And the AWS CLI is a tool that you download on your instance or your local machine, and it provides scripts that allow you to control multiple AWS services from the Windows or Linux or Unix or Mac OS shell. And then the AWS SDK, which provides EFS support for Java, Python, PHP, .NET, and others. And the Management Console, the CLI, and the SDK each allow you to perform a variety of management tasks. You can create a file system, you can create and manage mount targets, you can tag a file system, you can delete a file system, and you can view details on file systems in your AWS account. And you might notice that there's actually not a whole lot on this list, not a whole lot of functions on this list, and that's because there's not a whole lot that you need to do to manage your file system. So as I mentioned earlier, we designed EFS so that setting up and beginning to use a file system takes under a minute. And let me pause for a moment, because for those who've set up on-prem file systems or in cloud shared file systems, that statement's probably staggering. And keep in mind that after you create a file system, there's no maintenance after that point. So what do you need to do to create a file system? Well, first, through the CLI or through the console or through the SDK, you make a call to the EFS API to create a file system. The second thing you do is you create these mount targets that I was talking about. You create one in each AZ from which you want to access the file system from a VPC. Then the third thing you do is that you enable the NFS client on your instances. And again, the NFS client comes standard with almost all Linux distributions. And then you run the mount command that we were talking about on your instance. And that's it. You're up and running and able to start adding files to and reading files from your file system. And let me just show you what that would look like from our console. I have a few screenshots here that I'll walk you through. So what you're looking at right now is the start screen within the AWS console. And this is what you'll see if you're a first-time EFS user. So what you would do is you would click Create File System. Okay, so once you click Create File System, you get to step 1 of the Create File System wizard. It's a 3-step wizard. And on this first page, you configure file system access. So you specify the VPC from which you want instances to be able to access the file system, and you specify the AZs in which you want to create these mount targets. And for each mount target, you can specify the subnet it falls into. If you want, you can provide a specific IP address, and you provide security groups to associate with the mount targets. So all of the values that are on this screen right now are the default values that you'll see, or you'll see similar default values when you create a file system, and your file system will work with these defaults. So if you're happy with the defaults and you just want to quickly create the file system, all of this will be pre-populated. The second step is actually an optional step, and that's for adding tags. And you can add uh, a number of tags to your file system, and these are really for your benefit if you want to describe the file system in particular ways. We recommend that everyone, for example, creates a name tag. It's not required, but it's optional. And then the third step is really just a summary of the first two steps. It shows you the values that were provided in the previous steps and asks you to confirm. So then when you create file system, you click that button. That's it, you're done. The file system has been created and it can be mounted at this point. And what you're looking at right now is the detail view that you'll see for each of your file systems once they've been created that lists some of the basic properties of the file system, like where the mount targets are and the security groups associated with the mount targets, some basic information about uh, the size of the file system, tags associated with it, etc. Also, from within the console, there are basic instructions for how to connect to your file system, and similar to the process that I was mentioning earlier, you install the NFS client, you create a new directory on your instance, and then you mount to that directory using the DNS name for the file system. And at that point, your instance is able to write to and read from the file system. So hopefully that gave you a bit of a feel for what it's like to actually create a file system and what the process feels like. And at this point, we'll touch on a few topics that are a little technically deeper. The first is security. And we know security is critically important to customers, and it's critically important for us across all of our AWS services. As we designed EFS, security was absolutely top of mind. So let me talk to you about the security mechanisms that are available to EFS. First, at the network level, you can control network traffic to and from file systems, and it's really to and from mount targets, by using VPC security groups and VPC network ACLs. You can control file and directory access by using standard Linux and Windows directory and file level permissions. That's at the data access level. And then third, at the administrative level, you can control administrative access, or really API access, to file systems by using AWS's identity and access management. So I'll talk about each of these in a bit more depth. Now, before I talk about VPC security mechanisms, keep in mind that only EC2 instances in the VPC that you specify can access your EFS file system. So you create mount targets in only the VPC you specify, and mount targets are the endpoints through which the file system is accessed. So file systems cannot be accessed in any other way than through mount targets. And security groups, which are these firewall-like rules, are added to mount targets. And they specify what can send traffic to the mount targets, and therefore what can send traffic to your file systems. And security groups can have rules like only accept traffic from an individual IP address, only accept traffic from instances that are within a particular IP address range, only accept traffic from instances that are in the same security group. So just some examples of the types of rules that you can add to security groups. And in the example that's shown on the slide here, we've added to the mount target a security group rule to allow only traffic to and from instances that are part of that same security group. And EFS supports the standard permission model you're used to when working with file systems on Linux or in Windows. So it enforces user and group rights at the file and directory level. So for example, you can set permission for a file such that only the owner of a file can write to it. So only if the user account you're logged in with on your instance matches the owner of that file will EFS allow that client to write to the file. And in the Linux screenshot that you see on the slide here, you see that you, you can set read, write, execute permissions for owner group, everyone, like you would for any file or directory on a local file system. And integration with IAM provides administrative security. So you can use IAM policies to control who can use the administrative APIs to create, manage, and delete file systems. And EFS supports action level and resource level permissions. So as an example, you can specify that only a particular IAM user can create a file system, or that only a specific IAM user can delete a specific file system. And finally, let's talk about how we store data in a region. At launch, we'll be available in 3 regions. We'll be available in US West or Oregon, US East or Northern Virginia, and EU or Ireland. And in the near future, we'll expand to others. Okay, so in a region, data is stored in multiple AZs for high availability and durability. In the event of an AZ issue, so for example, if there's a natural disaster that impacts a particular data center, EFS file systems will continue to be available from other AZs. And you can design your application to take advantage of this. For example, you can use elastic load balancing or ELB to run your application in multiple AZs. So if one AZ is out, your application will continue to run and have access to the EFS file system. And it's important to explain that data can be accessed from any AZ in the region while maintaining full consistency. Your EC2 instances can connect to your EFS file system from any AZ in a region. And all reads will be fully consistent in all AZs. So a read in one AZ is guaranteed to have the latest data, even if the data is being written in another AZ. Okay, so wrapping up, I haven't talked much about pricing, so let me do so now. With EFS, you pay only for the storage space that you use. There's no minimum commitments or upfront fees, no need to provision storage in advance, no other fees, charges, or billing dimensions. So it's simple one-dimensional pricing, and the EFS price is 30 cents per gigabyte per month. So what can you do next? I'd encourage you to learn more by going to our website, which is aws.amazon.com/EFS. And on that website, you can request an invite for our preview. Our preview is starting this summer. And that is it. So thank you again. I encourage you to sign up for the preview so you can see for yourself how EFS is simple, elastic, and scalable.